Let's talk about linear equations application. So far we've talked about linear equations, how to solve them, rational equations, how to solve rational equations, not every type, but the ones that simplify to linear. Now let's discuss the linear applications, linear equations application. I picked a couple of examples to go through, and you will see similar examples in textbooks. You can look at other examples. I picked the ones that they haven't done in the book. So you can look at the other examples as well. Let's start with the first one. This is example number 1. Okay. How much of 4% acid solution should be mixed with 200 milliliter of 12% acid solution to make a 9% acid? So first, find out what is the value that you're looking for. Let's say I'm going to introduce a variable x. I'm going to say x is the amount of solution, 4% acid solution. So 4% acid solution. That's what we're looking for. How many milliliter or liters is this 4% acid solution? So this is the way the textbook uses. So I'm going to use their idea exactly the same way. There are the different types of acid. This is type 1. It has 4%. Second type is type 2. 1. If you do this mixture, you will get in total, this is the total, 9% acid solution. How about the amount? The amount of 4% acid solution, we have X amount, that's the variable that we do not know and we're looking for. The amount of type 2 is given 200 milliliters. In total, the amount of mixture that you will get is the 200 milliliter plus whatever amount that you add from the 4%. So this is the total amount is X plus 200. Now, what is the equation that you create? You have a 9% acid solution. And how do you get that 9%? Is through the mixture of the other two acid solutions. So the 4% acid solution, if you have X 100 milliliter, X milliliter of acid solution, 4% of that is basically saying 4% is the same as 0.04, 4 divided by 100, multiplied by X. This is the amount of acid per volume X, whatever X. The same with 12%, which would be 12 divided by 100, which is 0.12, times the amount is times 200. I'm going to use the parentheses here so you know these two are, this is not a decimal value. X is a value here, 0.04 is this. And if I add these two together, I'll get 9%. So I'll get 0.09 times X plus 200. This is the total acid ratio. So what do we get? We can create the equation as 0.04x plus the 0.112 times 200. I'm going to write the same thing. And in total, we'll get a 0.09 times x plus 200. And this is just a linear equation. They have only one variable x, and it has degree at most 1. There's no denominator. All the coefficients are real values. So you can solve this equation simply by moving terms to one side. So I'm going to do that. I'm going to simplify first. 0.04x plus 0.012 times 200. You can do this calculation. It turns out to be 24. And on the other side, you have 0.09x. I'm going to distribute that. Plus 0.09 times 200, that is 18. You can get rid of the 0.09 if you want by multiplying 100 to the whole thing. It's the same idea, it doesn't really matter. So now I'm going to move all the x's to one side. So let's subtract 0.04 x from both sides and add and subtract 18 as well. I'm going to move the x's to one side and the constant to one side. This way I did two steps, both of them at the same time. So these two will cancel out. These two will cancel out. Left side only turns out to be a constant. 24 minus 18, which is 6. Right side 0.09 minus 0.04, simply 0.05. And you find out what is x, you divide both sides by 0.05. 0.05. Okay, if we scroll down a bit. Let's write the solution. X equals, these two can cancel out, 6 divided by 0.05, that's the same as 6 times 20, which is 120. And you can check your solution back into the equation, see if it's really satisfies this equation. You can do that. Let's check maybe here. Let's pick a different color. Check our solution. 0.04 times 120. Instead of x, I'm replacing it into this equation. Plus 0.012 times 200 equals 0.09 times 120 plus 200. Then if you simplify 120 times 0.4, well, maybe calculator would have been a better choice. I think it's 4.8 plus 200 times 12 is 24. On the other side, 120 plus 200, this is 320. Multiplied by 9, 3 times 9 is 27, 28.8. Yes, and if you add the left side, you'll see that you have a true state. 24 plus 4.8 is 28. So this is our solution. This is the amount of milliliter, if you want to go, the unit of the 4% acid solution that you need to mix. It's all about setting up this variable. What they're looking for, you call it variable. The other type of application is for uniform motions. This is something that's very commonly used in physics. Find distance based on the speed and time. The distance, d, is ratio times time. This is normally you will use speed or velocity instead of ratio, but textbook uses ratio because it's just the symbol r. You might see in the other books is d equals v times t, v for the velocity, or s times t, speed times time. So you can look at it the other way as well. Velocity, or the ratio, is distance divided by time. You'll say I drove 100 miles in 1 hour. So 100 miles divided by 1 hour. That will give you the speed. 100 miles per hour, 60 miles per hour. That's how you calculate. So the distance basically is your speed times of the time that it took you to travel. So here is an example for this uniform motion. And this speed is not an instantaneous speed, it's an average speed, it's an overall speed. Let's look at this example. Ryder drove from Miami to Orlando in total distance of 240 miles. This is the total distance. He drove for 1 hour in the city and 3 hours in the highway. 3 hours in the highway. The average speed on the highway was 20 miles higher than speed in the city. Determine the average speed. So what are we looking for is the average speed, either in the city or the highway. If you find one, you should be able to find out the other. You have the choice to pick one of these two is your variable. You either pick the average speed in the city as your variable x. You either do this and say that's x, then the average speed in the highway would be x plus 20, because supposedly you go 20, he was going 20 miles faster. Or you can say, I'm gonna call the speed in the highway x, then the speed in the city would be x minus 20 miles slow. Either way is fine. It's just how you define the variable. Okay, so let's solve this equation. Let's solve this application problem. Here, x, we chose x to be the speed in the city. So the speed in the highway would be the speed in the city plus 20. The speed in the highway, x plus 20. Similar to the last example, I will set up the table and say, okay, at speed, time, and we're looking for the distance. There are given information. Speed in the city, we call it x. Speed in the highway, it's x plus 20. Total speed, we don't really know. We don't need it. Time spent in the city, 1 hour. Time spent on the highway, 3 hours. Total time, 4 hours if you want. Distance, how do you calculate the distance? Distance is the speed times time, or a ratio if you want. We call this a ratio. R times t, so x times 1 times x. The distance covered in the highway, it's ratio times time, so here 3 times x plus 20. And distance in total, since you do not have the overall speed, which you cannot do the multiplication, but you're already given the total distance. The total distance is given 240. So you've provided this information already. You don't really need to multiply anything on the right hand. So now you set up the equation. What do I know? I know only the total distance is a fixed value. It's 240. So if I add the distance covered in the city and the highway, I should end up with a total of 240. Distance 1 times x plus 3 times x plus 20 equals 240. This is what the equation becomes for the distance. 1 times x is x, 3 times x plus 20, 3x plus 3 times 20 is 60, equals 240. 1x and 3x, this is 4x plus 60, equals 240. You can subtract 60 from both sides, and what you will end up with is, I'm going to continue here, 4x equals 240 minus 60, 180. And if you divide both sides by 4, these two can cancel out. What do you get for x? 180 divided by 4, 160 divided by 4 is 40, so 45. 45 miles per hour. Miles per hour. Okay. So what is this x that we found? X was the speed in the city. This was 45. We found that the x, which was the speed in the city, this is 45. What about the speed in the highway? It's 45 plus 20, 60 miles per hour. So you can answer both questions either way. You can check your solution, by the way, as well. You can place 45 in its original equation here. 1 times 45 is 45. 45 plus 20. You can replace 45 here for both x's. 45 plus 20 is 65 times 3 is 195 plus 45 becomes 240. So you will see that this is a correct solution. As we go on, I will maybe start skipping certain steps, but you shouldn't always check your solution. Make sure that this is the correct solution. Sometimes you make a calculation mistake. So by checking your solution, you will figure out maybe you did something wrong somewhere. Okay, the other application for linear equation is through proportion. Proportion is comparison between two ratios. You're given A divided by B, which is a ratio, C divided by B, another ratio. Like two fractions, you will have 2 over 4 equals something divided by 6, and you want to figure out what is that something. It's just a comparison. You can say this is 3 over 6. They both give you the same value. Either if I give you the 3, you can find out the 6, and so on and so forth. So you will set up a structure that they have the same ratio on both sides. The only thing is that you should be careful that the denominators are not 0. If you remember, it's an undefined value if you have 0 in the denominator. So let's look at this example. Again, there are other examples in the book as well. I picked the one that has no solution. So for the 104th Congress, there were 4 more Republicans than Democrats in the Senate. The results in ratio were 13 Republicans to 12 Democrats. How many senators were Republican, how many were Democrats? Again, you have the option to pick the number of senators that were Republican as your X value, and the number of Democrats would be, since there were 4 more Republicans than Democrats, this must be X minus 4. You can pick the number of Democrats to be X, then since the number of Republicans were 4 more, you should write X plus 4 for the number of Democrats. It's all depending on how you pick your variable, what your variable represents. So here in this case, I pick X to be the number of Republicans, therefore the number of Democrats or 4 less, so X minus 4. What you're given is a ratio, number of Republicans to the Democrats, so you're given the Republicans to Democrat ratio, which is 13 over 12. So what do we know? Number of Republicans is X, number of Democrats, X minus 4. Still have the same ratio as the 13 over 12. And now this is your equation. 13 over 12 equals X over X minus 4. The question becomes, how do you solve this rational expression? You can always get rid of the denominator. What you multiply is the common denominator. I will multiply 12. This way I will get rid of this 12 in the denominator. And I will multiply an X minus 4 to get rid of this X minus 4. But whatever you do on one side of the equality, again, you should do it exactly on the other. If I do this multiplication, 12 and 12 will cancel out. X minus 4 and X minus 4 will cancel. So what do we have? We have 13 times X minus 4 on the left side and 12 times X on the right side. Distribute the 13. You get 13X minus 13 times 4, that is 452, equals 12. I may make mistakes as we sometimes will do the multiplication. And just make sure that you're following, and if there's a mistake, you can fix my mistake. 13x minus 52 equals 12x. I subtract the 12x from both sides. What do we get is 0 equals x minus 52. And you can add 52 to both sides. We'll end up with x equals 52. Is this the correct ratio? So let's try it into the equation. 13 over 12 equals 52 plus x divided by 52 minus 4, 48. If we simplify 52 over 48, do we get 13 over 2? I think we do. If you divide, choose the color red, if you divide this by 4, 52 divided by 4 is 13, 48 divided by 4 is 2. So this is the same as the 13 over 4. This is true. This is our solution, x equals 52. So I can say the number of Republicans is 52. You should answer the question that they want. How many senators are Republican? Number of Republicans is 52. Number of Democrats, 52 minus 4, 40. Again, since I picked number of Republicans to be X, the number of Democrats became X minus 4. You can choose it to be the other way around. Republican number of Democrats to be X, and number of Republicans would be X plus 4. It's all optional. They should both give you the same solution. You can try it with this one, see if you get the same number. Okay, these are the three examples that I picked for the application. You should look at the homeworks and textbook examples as well. They are very similar to these examples today. Let's continue next time.